In this class, we're going to study Lesson 5 in in Modern Arithmetic 2. Lesson 5 in Modern Arithmetic 2. So let's take a minute and prepare our notes for this class. The title of the course is Modern Arithmetic 2. And we said that the title of this course, which is important for us to remember, the title of this course, the title of our math textbook in this course is Intellectual Arithmetic. So there's something different about this course from Arithmetic 1. And we have to make sure that the way that we study this course is different from Arithmetic 1. And I've talked about that. What's different about Intellectual Arithmetic and Modern Arithmetic 1? What's different? How did we study arithmetic in...
Arithmetic 1, you count with beans.
That's right, good. You count with objects, okay? In Modern Arithmetic 1, we counted with objects. We thought about objects. In Intellectual Arithmetic, what's the difference? What are we trying to learn to do in this course, yeah?
We're going to count with our minds.
Right, we're going to learn to count with our minds. Good. All right? So in Intellectual Arithmetic, we learn to count, to add, to subtract, and so on, etc. means and the rest. We learn to count, add, and subtract intellectually, in our minds. That's the goal of Intellectual Arithmetic. Okay? To learn to count, add, subtract, multiply, divide in our minds. And there's a reason for that. Later on in arithmetic, you're going to learn that there are two different kinds of numbers. There are concrete numbers, and there are abstract. Concrete and abstract numbers. When we think about concrete numbers or talk about concrete numbers, we think about objects. We think about specific objects. All right, so I may say $5, 10 inches. Okay, when we talk about concrete numbers, we think about and talk about, maybe even handle objects, units, and so on. If we talk about $5, we're talking about $5 bills, or the value of a $5 bill. If we talk about 10 inches, we're likely looking at a ruler or looking at a tape measure. We usually don't talk about inches and feet without looking at a measuring tape or a ruler, right? You don't have in your mind how much an inch is. It's very hard to guess. If I were to hold up a piece of paper and say, how wide is this? It's hard to guess, right? If I say, how far is it from here to the tree? It's hard to guess. You know? Usually we have to measure, and we look at the units on the measuring tape or on the ruler. All right? Concrete numbers, we think about objects. We talk about objects. But abstract numbers, we don't think about objects. We just think about the numbers themselves. We think about the number 5 by itself. We think about the number 10 by itself. Those are abstract numbers. Okay? So one of the important differences between primary arithmetic, or arithmetic 1, and intellectual arithmetic, arithmetic 2, is we're trying to grow in our minds. We're trying to grow intellectually so that we don't have to always think about concrete numbers, but we can think about abstract numbers. Do you understand that? And if we memorize and learn everything about abstract numbers, we simply use that knowledge to talk about objects. But what we learn in abstract numbers applies to any objects. You see? So we want to learn to think with abstract numbers, and then we can talk about concrete numbers. Okay? You understand that? But when you're a little baby and you're just getting started in math, the only way you can understand numbers is to think about objects. Now we're trying to move from objects just to thoughts about the numbers themselves. Okay? So if I wanted to add in arithmetic 1, I would say something like, Joseph had $5 and his grandmother gave him $3 more. How many dollars did Joseph have then? And we would say $5. I could count $5, right? I can hold $5 in my hand and I can say, okay, Joseph had $5 and then his grandmother gives him 1, 2, 3 more. So now there's $5 and $3. How many does he have now? And you can count the dollars. 1, 2, 3, 4, $5, $6, $7, $8. Joseph has $8. And that's arithmetic 1. That's baby arithmetic. Counting and talking about objects. Okay? In intellectual arithmetic, we do it differently. If you say, Joseph had $5 and his grandmother gave him $3 more, how many does he have then? You can say, oh, he has $8. And then if we ask, how do you know he has $8? You didn't even touch the dollars. How do you know that? How do you know there's $8 if you didn't even pick them up and count them? And you can say, oh, because I know that 5 plus 3 makes 8. And because I know that 5 and 3 make 8, I know that $5 and $3 make $8. I don't have to pick them up and count them. I know how many dollars are there because I know that 5 and 3 make 8. And it doesn't matter if it's dollars or beans or bicycles or cactuses or anything else. It doesn't matter what the objects are. 5 and 3 will always make 8. It doesn't matter what the objects are. You see the difference? The student who knows that 5 and 3 are 8 knows what 5 and 3 dollars are, knows what 5 and 3 pennies are, knows what 5 and 3 basketballs are. It doesn't matter what the objects are. He doesn't have to pick them up and count them. He knows that 5 and 3 are 8, and he can answer any question about objects. You understand that? Okay? So that's the difference. We're trying to move in our thoughts from objects like babies who need to count beans and pennies to become better students, more mature students, reasoning students who think about abstract things, who don't have to have something in our hand to count, but we can think about the numbers themselves. So that's the difference between arithmetic 1 and arithmetic 2. So in lesson 5, we're going to study some questions, simple addition questions, but we're going to answer them intellectually. Okay? We're not going to answer them like babies. We're not going to pull out our beans and spill our beans all over the table so we can count. We're just going to think. We're just going to think, okay? So look with me at lesson 5, and we're just going to go through a bunch of questions in this class, okay? So let's look at lesson 5. Now, lesson 5 assumes that you already have memorized the addition facts, okay? So if you haven't memorized the addition facts, you need to do that before you study lesson 5. But if you have learned the addition facts, let's work on lesson 5 and practice intellectual arithmetic. Okay, let's look at number 1. We have a question, number 1 in lesson 5. Our textbook asks us 3 and 6 and 4 are how many? Now, it's not asking you to be a calculator and just tell the answer. I already have a calculator. I have a phone right here in my hand. If I needed to find the answer, I could just type the numbers in my calculator and find the answer faster than you. That's not what this class is for. We don't simply want to find the answer. We want to find the solution. And the solution is different from the answer. The answer we can get from a calculator. The solution is an explanation of how to find the answer. Because anytime you answer a question or solve a problem, you need to prove that your answer is true, right? Who cares if you say the answer? I could say, how many are 5 and 6? And you could say 4. Well, how do you know that you're right? How can you prove your answer? Okay, so the solution to a problem is not just finding an answer and shouting out an answer. The solution to a problem is an explanation that shows how to find the answer. It's a proof of the answer. It's a proof of the answer, okay? So let's look here at lesson 5. Question 1, we have a question, 3 and 6 and 4 are how many? It's not just asking us for an answer. Under the question, you see that there's a solution. You see that? That solution is showing you how you should answer this question. That solution shows you how you should answer the question. You see, they don't just yell out an answer. They give a solution. All right? So just read the solution for me. I'm going to ask the question. Ready? 3 and 6 and 4 are how many? Read the solution out loud.
3 and 6 are 9, and 4 are 13.
That's how the question is to be answered. That's the solution. Okay? So 3 and 6 and 4 are how many? The solution is 3 and 6 are 9, and 4 more are 13. That's the solution. Not only does it tell us the right answer, not only does the solution tell us the right answer, but it tells us how to find the right answer. Do you see that? Okay? And notice what they did when they were given 3 different numbers to add. They added the first 2 and found the sum of the first 2, and then they added the third number, and they found the final sum. You got that? So I know that this is easy. It's easy to find these answers, but we're focused on learning how to find the solution and give the solution, not just say the answers. All right? Because what's going to happen is the questions are going to get harder and harder. And if you don't know how to give the solution, you're not going to be able to solve the harder questions. Anybody can solve these questions. These are easy. Right? But we're not learning how to find the answer. We're learning how to find the solution. That's different. Okay? So question number 2. 4 and 5 and 7 are how many? Who can give me the solution? You can try?
4.
Clear. Just speak slow and clear, okay? Don't speak quickly.
4 and 5 are 9, and 7 are 16.
Good. 4 and 5 are 9, and 7 are 16. The total is 16. So you have to know your addition facts to do this, right? You have to know the addition facts. Number 3, 5 and 6 and 2 are how many? You want to try one? Go ahead.
5 and 6 are 11. 5 and 6 and 2.
No, just do 5 and 6 are 11, and 2 are,
13.
right, 13, okay? So that's how you give the solution. And you just have to calm down, right? One problem that you have with speaking, let's talk about speaking for a minute. Our minds can work very fast. Our minds can work very fast. You can take a book and if you just look at the words and let your mind read, you can read very, very fast. Way faster than you can talk. And the problem is when you try to talk sometimes, your mind is moving like a race car, going through ideas very fast. And your mind wants to share those ideas very fast. Your mind is ready to just speed through all those ideas. But the problem is you can't speak as fast as you can think. And you have to learn not to try to speak as fast as you think. You have to learn to slow down, let each word come out clearly, and share one idea at a time. Okay? So our minds work very fast. And when you don't practice speaking well, you try to speak as fast as you think. And you just talk like, right? And you have to learn to slow down, because even though you can think fast, you can only speak as fast as your mouth can make the different words. Do you understand that? Okay? So you have to learn to, when you speak, you have to slow down. Slow your thoughts down and speak them one word at a time. Okay? So that's why when I ask you the question and you get sort of nervous and you start to stutter and mix all your words, it's because your brain is like boom, 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 boom. And you try to talk that fast, and you have to learn to just slow down. So what's helpful is to think before you speak, right? Because when you think, you can just let your brain work as fast as it wants to. That's why we learn a lot more by thinking than by speaking, because our brains can go fast. But when it's time to speak, you have to slow down and say one idea at a time. Speak one word at a time. Okay? So you have to learn when it's time to talk, you have to learn to calm down. All right? So let's look at the next one. Question 4. 6 and 4 and 5 are how many? Go ahead.
6 and 4 are 10, and 5 are 15.
Very good. Okay? You did better that time. Just slowing down. Right? Slow down. Your brain can shoot through all the answers, but your words, your mouth has to move more slowly. Okay? All right, let's go on to the next page. Now I want you to see in your book, there are like a million different questions, right? You see all that? And you don't necessarily have to answer every single one of these questions. When this book was made for a class. So a teacher could say, okay, you do number 5, you do number 6, you do number 7, and the kids would come up to the board and they would sometimes write their answers on the board or give their answers one by one. All right? So there are many questions, and we don't necessarily have to answer every one. So let's try the next one, number 5. And what we see is it gets a little more complicated, right? A little more difficult. Now we're adding how many numbers? 4 numbers. All right? And the solution taught us how to do it. You just go with the first 2, and then you add the next one, and then you add the next one until you find the final answer, right? So number 5, 7 and 3 and 5 and 2 are how many? And I want you just to, when you answer, just take your time. Take your time. Think and speak. There's no rush. There's no rush. 7 and 3 and 5 and 2 are how many?
7 and 3 are 10, and 5 are 15, and 2 are 17.
Good. 7 and 3 are 10, and 5 are 15, and 2 are 17. Number 6, 8 and 2 and 3 and 4 are how many? Do you want to try it? Nice and slow and clear.
8 and 2 are 10, and 3 are 13, and 4 and
13 and 4 are
17.
17. Good, that's the answer. Let's look at one of these questions because I want to help you when you have an addition fact or something like that that's maybe a little bit difficult. And sometimes we just get confused, right? Sometimes you just can't think of the answer quickly. It's okay. I want to show you an easy way to do this. If you have to add 3 and 4, that's easy, right? 3 and 4 are 7. That's easy. Okay? But what just happened to you was you had to add 13 and 4, and you're trying to think of what the answer is. Okay? When you start getting into higher numbers, what you need to learn is to think about a higher number as 110 and 3 units, or 3 ones. Because this is 4 ones. Right? So if you have to add 13 and 4 in your head, you don't have to add 13 and 4 more. You just have to add 3 ones and 4 ones. And that's easy. Right? And then you just remember that 10. So it's just what you're actually adding. You're not adding 13 ones and 4 ones. Sometimes it's hard to think like that. How do I add 13 ones and 4 ones? How do I add 19 ones and 37 ones? That's really hard. Okay? But if you think that what you're adding are 110, 3 ones, and 4 ones, it makes addition very easy in your head. You see? I have 110 and 7 ones. Right? You see that? Daniel, you see that? I don't have to add 13 ones and 4 ones. I can just think I'm adding 110 and 3 ones and 4 ones. 110 and 3 ones and 4 ones are 110 and 7 ones. And that's 17. You see that? All right? So if you have to add 25 plus 34, well, that would be hard to do in your head, right? And some kids would think, oh, I need to write it down on a piece of paper. But that's not intellectual arithmetic, right? We don't want to write it down on paper. I have a calculator right here. My phone has a calculator. If I want to find the answer, I could just type the numbers in my calculator, but that's not what I want to do. I want to learn how to solve problems intellectually. I want to know how to find the solution. Well, if you try to add 25 ones and 34 ones, that's very difficult, right? Follow me here. If you try to add in your mind 25 ones and 34 ones, that's difficult. But you don't have to do that. You can think 25, what 25 tells me is that I have 2 tens and 5 ones. And I'm adding 3 tens and 4 ones. What's 2 tens and 3 tens? 2 tens and 3 tens are 5 tens. And in intellectual arithmetic, how do you know that 2 tens and 3 tens are 5 tens? 2 tens and 3 tens are 5 tens because
2 plus 5 is 10.
no, you didn't read it right. 2 plus 3 is 5. Right? So if you think of 25 as 2 tens and 5 ones, and you add 3 tens and 4 ones, that's very easy. 2 tens and 3 tens make 5 tens. 5 ones and 4 ones make 5 ones and 4 ones make 9 ones. And what number is made up of 5 tens and 9 ones? 59. And you can do that in your head. You can do that intellectually. If you learn to think of the numbers based on how they're written and how we express numbers, you don't have to think of this as 25 ones. You can think of it as 2 tens and 5 ones. And you don't have to think of 34 as 34 ones, because it's very hard to add like that. But if you think 2 tens and 5 ones and 3 tens and 4 ones, you can add them very easy. Ready? Let's try another one. Try to add these intellectually. If I have the numbers 42 plus 57. In your head, don't write anything down. You want to try it? Okay. What's 42 and 57? Go ahead, explain the answer. Explain the solution for me.
There's 4 tens and 42, and there's 2 ones.
Right. Mm-hmm.
And there's 5 tens and 50s, so and there's 7 ones.
Right.
And 7.
Okay, go ahead. Explain the solution.
4 tens and 5 tens are 9 tens.
Okay, good. So we have 4 tens and 5 tens are 9 tens.
Plus 2 ones and 7 ones are 9.
Are 9 ones, right? It's very easy. You can add great numbers very easily using your simple addition facts by thinking of the numbers as tens and ones rather than as just a bunch of ones. Okay? So the reason why I'm telling you this, and make sure you pay attention, is because when you go through these exercises and you have to add 4 or 5 different numbers, you're going to get into 10s and 20s, and you have to be able to keep using your mind to answer the question, right? You got to the end of that question and you had to answer 13 and 4 are, and all of a sudden you acted like you were confused, as if you don't know what 3 and 4 are. Because you were trying to add 13 and 4 instead of just adding 1 10 and 3 ones and 4 ones. You see that? Okay? So when you have harder problems to solve, just look at the parts. Look at the parts and add the parts. Because that's how our numbers work. All right? So let's go back to our lesson. Number 7. Number 7. This is going to be a difficult one. 9 and 2 and 4 and 3 are how many? Now, what this is teaching you is just get started with the solution and just work from the beginning to the end. You don't have to sit there and find the answer first. You can just start answering. If I ask you, how many are 9 and 2 and 4 and 3? You can just start answering and say, 9 and 2 are 11. And 4 are 15. And 3 are 18. So you can immediately start to answer the question with the solution by simply adding one number at a time. You don't have to sit there and think and find the final answer first before you can answer. Do you understand that? All right? And you just did the same thing he did before. When you got to the point where you had to add 9 and 2 are 11, and 4 are 15, and 3 are, you started thinking, how many are 15 ones and 3 ones? Right? Instead of thinking, how many are 5 and 3? I know that's easy. 5 and 3 are 8, and 1 10 is 18. You see how much easier that is? When you try to add large numbers of ones, it gets confusing. And that's not how our numbers work. Our numbers are not expressing ones. Our numbers express tens and ones. Okay, so let's try another one. Number 8. 2 and 8 and 5 and 4 are how many? Start the answer. 9 and 2. No, we're on number 8. 2 and 8 and 5 and 4 are how many?
2 and 8 are 10, and 5 is 15, 15 and 4.
You're doing it. You're thinking of 15 and 4, where all you have to think of is 1 10 and 5 ones and 4 ones. What's 5 and 4?
5 and 4 are 9.
And what's 1 10?
So it's 19.
19. All right? The problem is once you get to those higher numbers, you don't think about tens and ones, you just think about ones. Right? And the answer is actually very simple. Let's try one more. Number 9. 3 and 9 and 5 and 4 are how many?
3 and 9 are 12, and 5 more are 17, and 4 more are 21.
Good. Okay. 3 and 9 are 12, and 5 are 17, and 4 are 21. Okay? Now, what you see is that to solve these problems, you don't need to sit there and think about the final answer before you answer. You can begin solving the problem immediately by starting with the first numbers, adding them, and then just adding one more number as you go through. Right? And so to solve all of these problems, you just need time. But what the problem is, you see there are two possible problems. One, you may not have all the names of the numbers memorized. Right? Once you get past 10, 11, 12, between 12 and 20, those numbers are hard for young students. Right? 13, 14, 15, 16, 17, 18, 19. Those numbers can be hard to remember. Once you get past that, You just have 20, 21, 22, 23, 24, 25, 20. That's easy, right? But 12 to 19, the names of those numbers have to be memorized. You see that? Okay? So the first problem you can have is that you just don't have the names of the numbers memorized really well. And the other problem is you don't have your addition facts memorized very well. Okay? So if you find yourself having trouble with these exercises, it's because you don't have the simple addition facts memorized very well. You might think you do, but when you actually have to solve a problem, you find that you don't have the facts memorized well enough to answer them quickly. Right? And so you can do exercises like this. If we practice some fast math, okay, a good way to practice addition, this is something you can do if you test yourself or whatever. You can just do this. Think of a triangle. Ready? This is pretty cool actually once you learn it. All right? Think of a triangle, and in each triangle there are going to be 3 numbers. Ready? I'm going to write 2 numbers, and then you're going to say the sum is the 3rd number. Ready? So what's 2 and 5? 7. You see that? Think of the numbers together as a triangle. And watch how cool this is. 2 and 5 are 5 and 2 are 7 minus 2 leaves 7 minus 5 leaves. You see that? So if you think of these numbers in triangles like this, you'll just always remember that these 3 numbers are together. And you can think of the answers to addition and subtraction problems very, very quickly. You see that? Okay? So you can make flashcards for yourself that look like this. Let's try another one. Okay? And you'll see how you can see the numbers. Go ahead. 6 and 2 are?
6 and 2 are 8.
2 and 6 are?
8.
8 minus 6 are?
2.
8 minus 2 are?
6.
6 and 2 are?
8.
2 and 6 are?
8.
8 minus 2 are?
2. 6. No, 8.
8 minus 6 are?
2.
Okay, so you see if you set up these little number triangles, they help you with addition and subtraction. And what happens is if you study number triangles like this, you'll just memorize the 3 numbers that are together in the triangles. And anytime you see the 2 numbers, you'll think of the other number quickly. You see that? Okay, let's try another one. 5 and 3 are?
8.
3 and 5 are?
8.
8 minus 5 are?
3.
8 minus 3 are?
5.
Okay, so if you make flashcards for yourself like this, for all of the addition facts in your lesson, right? If you go back to that, lesson 3 I think it was, where you had the whole table of all of the addition facts, if you take time, take some index cards and make addition flashcards for yourself like this, you can very quickly memorize all of the addition facts and all the subtraction facts with these cards. You see that? Okay? Sometimes flashcards will be like this, and the flashcard will say 5 plus 3. The flashcard will look like this, and then the answer is on the back. But that doesn't really help you because you actually want to see all the numbers together. You want to see these 3 numbers together, 5, 3, and 8. And if I ask you, what are 5 and 3, your mind will remember that the other number was 8. 5 and 3 are 8. 8 minus 3 is 5. 8 minus 5 is 3. 3 and 5 are 8. You see that? So don't use flashcards like this. Make for yourselves flashcards like this. Because this also will work for multiplication and division. Watch. In multiplication and division, if I have 2 and 3, 2 times 3 are 6. 2 times 3 are 6. 3 times 2 are 6 divided by 2 is 6 divided by 3 is, see how easy that is? You see that? Okay? So if you make for yourselves these triangle flashcards, these number triangles, it will help you to master all these math facts. And your mind will remember these triangles. You understand that? And you'll be able to think of that third number. Because when we have an addition problem, what we're really being asked is, what's the third number? 5 and 3 are 8. That's the third number. You see that? Flashcards like this will help you with your memory work. So if you still have to work on your addition facts, make cards like this. And you'll memorize them really fast. Okay? Now what I want you to do for this lesson, if we scroll through, there are 53 questions. 53 questions. And what I want you guys to do, because we want to really master these questions, I told you that they give us a lot of questions in this book because they were intended for classes where a student can give different questions to different students. But I'm a mean teacher, and I want you to do all of the questions. So for your exercises for this lesson, I want you to answer every one of these questions in your assignment, and you have to write out the answer the way that the solution shows you. Do you understand that? So I don't want to see just answers typed in, because that's not the solution. I want you to type out the solution. And you could say, oh, that's a lot of work. Yeah, because that's how you need to study to practice and master things. Okay? You master things by doing it over and over and over again, not by doing it one time. Just because you can get the answer one time, that's not mastering it. So for the exercises for this lesson, you're going to do all of those 53 problems and write out the solutions. Okay? And in the meantime, set up for yourselves these triangle flashcards to help you memorize your addition facts. Okay? So take some time on the bottom of your paper and write a summary of what we did in this class, what we talked about, and that's going to be all for our class on Lesson 5 in Modern Arithmetic 2.